All right, here we want to talk about functions. So a function is basically described where you have a dependent variable that's changing with respect to the independent variable. What we like to do is call the dependent variable the y value or the y variable, and the independent we would call the x value or the x. Now, we can also look at this as far as what we would think of as an input and an output. So our x value, our independent value, is going to be what we input into the function, and our dependent variable or our y value would be our output, what we get out of the function. Okay, so you can think about it as kind of a machine here. I'm going to input the x values or independent variable. It's going to go through some sort of a function, and then it's going to output a y value or a dependent variable. Okay, so if we kind of think about it like that, it might make a little bit more sense. Now this function that we talk about, that's what we call that f of x. It's saying the function f that we put our x, our input of x in, all right? And that's going to output, it's going to equal the y. So we kind of see that here in what we call our function notation, all right? So now that we kind of know what a function is, let's see if we can identify the pieces of the function, okay? So looking at this first example, it says, you have an expensive bill and you want to know how the cost of the bill depends on the amount of time you spent on the phone. So we have to think about what is the independent variable? What are we putting in and what are we getting out? Our dependent. Okay, so our independent value is going to be the amount of time you spent on the phone. That's what we're going to put into our function so that our output would be this bill. So our dependent variable is going to be the bill. Okay, let's look at our next example here. It says you run different distance intervals on a track and you want to know how your heart rate depends on the distance that you run at a fixed speed. So if I'm looking at this, what I'm putting into the function, my input, my independent variable, is going to be the distance that I run. Okay, that's going to be our independent, our x value, our input. And then what I would get out of that would be the heart rate. It's going to be my dependent variable. Okay, so sometimes they're nice enough, not always, to use this word depends. They don't have to use that word, but sometimes it might help us a little bit to identify which one is which. Okay. They could write it another way. So let's look at this second example. They could write it as far as looking at our independent, our x, comma, y, like an ordered pair. That's going back up here to where we have independent variable, comma, dependent variable, which would match up with that x, comma, y. So let's look at this. It says the size of a file and then the time to download the file. Okay, so what we want to think about in general is what would happen with these, okay? If I think logically here, the bigger the file, the longer it takes for it to download, right? We kind of see that especially now as we're trying to use so much technology. So the bigger the file, the longer the download. Okay, so what that means is as the file is increasing, so is the time to download. Okay, so let's see if we can match that up. So now remember, we have to think about what is our input. The first thing we have to do is know the size of the file, so we know how long it will take to download. Okay, so the first thing that has to occur is the independent. That has to happen first. So the first thing I can do is I can automatically take off C and D because they're talking about the time being the first thing. That's not what we want. So we want, as the file increases, the download file also increases. So my answer there would be B, right? So now that we've kind of looked at what a function is, let's see if we can look at some of the specifics about a function. So in math, there's a couple ways to look at a function. One way to look at it is a table of values. Okay, another way to look at it is a picture. A lot of people like to look at a picture to help explain things. So we would look at a graph typically. All right, and then we can also look what most people think, oh, that's straight math because we see an equation. Okay, so there's 3 different ways that we want to represent a function: a table, a graph, and an equation. All right, so when we look at these things, we want to analyze each of these different ways of representation. One way to analyze this is with the domain and the range. Okay, we want to think back to the basics of a function. The basics of a function is we have an input, an independent, an x, and we have a dependent, an output, a y. Okay, so we want to relate everything we're doing to those 2 basic elements. Okay, so when we look at domain and range, domain is actually the independent variable. So now we've got our list of vocabulary here. We've got independent, which is the same as input, which is the same as x value, which now we can add in there is the same as domain. All right. Then we have this idea of a range. The range is going to correspond to the dependent variable. Okay, so now we can make our next vocabulary list. We've got dependent, which is the same as output, which is the same as y value, which is the same as our range. So there's lots of different ways they could ask me a question, and they're really asking me the same exact thing. So I have to know kind of how to work through that vocabulary. All right. Now, when we look at this, we have to know how are we going to read that. Okay. So one way that we want to look at, like we said, is our data table. So looking at our data table here, we know that our x values are independent will be first because it's going into the function, and our y value will be second because it's going out of the function. Okay, so now that we know that x and y is there, we also know that this is the independent and this is our dependent, which means that this first column here is the domain. And our second column here is the range. Okay. So we can do the same thing in our graph. Okay, so looking at our graph, we can remember that the x-axis is the horizontal axis, the y-axis is our vertical axis. The x-axis would then be our independent. I would see my domain occurring there. Okay. My y values would be my dependent, and I would see my range values occurring there. Okay, so now that we can read those, let's see if we can answer our questions. All right, so it says identify the independent and dependent. So our independent, we know, is that altitude. All right, and our dependent is then going to be the pressure. All right. It says, what is the domain of the function? Now, when they're asking me for the domain, I don't want a vocabulary word. I want numbers now. Okay, so I want to know what are the values that are associated. Okay, so if I'm looking at my x values, I can say that my domain is going to be anywhere from 0 feet to 30,000 15,000 feet. Now, sometimes in math, we would represent that kind of in what we would call an interval notation. Okay. Notice that I'm using brackets and not parentheses. The difference, sure, we probably don't remember, it's kind of very specific, but I would use a bracket if something is included, if it can actually equal. So since I have 0 on the table and 30,000 on the table, I'm going to use a bracket. If it was not included, say it was going off to infinity, I would use a parenthesis. Okay. So parenthesis is not included, and a bracket is included. Okay. Most of the times we'll look at brackets here. Again, unless it just goes off to infinity, it's never ending. Okay. So now I want to look at my range. So the range, we want the values related to the pressure. So when we look at this range, we're going anywhere from 10 to 30. So we're going from 10, and this is in mercury, to 30. Okay. So again, I could write this as an interval from 10 to 30. Right? So now let's look at the next question. It says, find the value of the atmospheric pressure at 15,000 feet. So I can do one of two things. I can look at my table and estimate a little bit. So I know that at 15,000, I'm going to be somewhere between 16 and 22. Okay, I can maybe get a little bit more accurate if I look on the graph here. So at 15,000, you see they've kind of shown us here. I could read this point to be somewhere about 18 inches. So I could read it from my table and give a little bit of an estimate. Okay. I could also read it from my graph. Again, looking at my X value to be the 15 and then going across to see where the Y value would be. So I would get 18 in mercury. I think that's Hg. Oh, I see down here they're showing it inches Hg. So let me put inches Hg. Okay. Then the last question says, at what altitude is the approximate atmospheric pressure 12 inches mercury? So again, I can read from my table if I wanted to and make an estimate. So if I was looking at my table, what I would need to do is come over here and say, okay, well, it's going to be somewhere between 10 and 16. So what I would be somewhere between 20 and 30,000. Or I can come over here to my graph and I'm going to look at, okay, well, if I want about 12, let me read that right across. It's going to be somewhere about, I'd say a little bit closer to 30,000. So maybe approximately, remember it says to approximate here. So I'm going to say approximately 27,000 feet. Okay. So now hopefully we should be able to look at a function, identify what's the input, what's the output, what's the independent, what's the dependent variable. And then we should be able to read from a table, a graph, looking at those different values and analyzing pieces of that function.